So in problem number 3, we have this table. So we don't need to remove the unreachable state and the dead states. Okay, since we start with the table, the transition table. Okay, so in the transition table, Q0 is the initial state, while Qt is the final state. Okay, so now let's move on. Let's skip step 1 and step 2. Let's proceed with step 3 for the theorem. So let's consider step 1 here. So get the logical equivalent, the equivalent zero rather, equivalent zero wherein we're going to group the non-state, non-final state as one group and another group for the final state. So final state, we only have one, Q2, and here Q0, Q1, Q3, Q4, Q5, Q6, Q7 are non-final state. Okay, so now let's proceed with step 2. So let's get the equivalence 1. Okay, so for Q0, Q1 within this group. Okay, how about Q1, Q6 when it encounters 0 within the group. For Q0, Q5 within the group. But for Q1, it's Q2, other group, the final. So therefore, Q0 and Q1 are different group. Okay? So they are not equal based on the behavior of 0 and 1 result. Now let's proceed with Q3. Q3 go to final state, which is Q2 when 0. So therefore, Q3 is different from Q0 and Q1. Since Q0, Q1 will just stay within this group, non-final state. While Q3, when it encounters 0, it will go to Q2. So Q3 is separate from Q0 and Q1. So Q2, definitely this is separate since this is final state. Okay, let's proceed now with Q4. Will Q4 be a different group? Let's check. Q4 will go to Q7 if it encounters 0. Same group, correct. Q5, same group when it encounters 1. Which among these three is the same as with Q4 rather? It's Q0, am I right? Q1, Q5 is the same group. Q7, Q5, same group. So therefore, Q4 is grouped with Q0. Okay, now let's proceed with Q5. Q5, when encounter 0, go to final state, which is Q2. Which among the early state have this result? When encountering 0, go to the final state. We have Q3. So there's a possibility that Q3 and Q5 are the same. Okay, so let's check 1. Q6, same group. Therefore, Q3 and Q5 have the same behavior. Therefore, they are grouped. Okay. Now, Q6. Q6, when encounter 0, will just loop within self. So, same group, non-state. Q4, Q6 will go to Q4 when encounters 1. Same group, which is the same as Q0 and Q4. How about Q7? Q6, same group. Q2, final state, the same as Q3, Q5, and Q7. Okay, sorry, Q1 and Q7 rather. Okay, so it's the same as with Q1, Q7, not Q3, Q5, sorry. Okay, so this will be the grouping with equivalence 1. Now, after the grouping, new group, let's proceed with equivalence 2. Can we separate further the grouping? Okay, so let's start with Q0, Q4, and Q6. Q0, Q1, go to this group. Q5, third group. Q4, third group. A second group rather. Q5, third group. So Q0 and Q4 are the same based on this, based on the behavior. So if it's 0, it will go to this group. If it's 1, it will go to this group. How about Q6? Q6 go to the first group, which is now different from Q0 and Q4. Okay? If still remember, Q0, Q4, if it's 0, it will go to Q1, Q7. But for Q6, it stay within the group. So therefore, they will be separated. Okay? And then, let's proceed with Q1, Q7 group. Q1, Q6, Q2. 7, Q6, Q2. Definitely, they are in the same group since they have the same result with 0 and 1. How about Q3 and Q5? They are the same, Q2, Q6, Q2, Q6 for Q3, Q5 respectively. So they belong to the same group and definitely our final Q2. So this will be our P2. Now let's proceed with equivalence 3 in case we could further separate the different states, okay, that which currently been grouped in equivalent 2. Okay, how about, so let's start with Q0 and Q4. Q0, Q1, Q5, third group, fourth group. Q4, Q7, Q5, third group, fourth group. Same behavior. So still Q0, Q4 belongs to the same group. Q6, since it's just one, definitely just Q6, Q1, Q7 are the same based on P2. So we don't need to analyze it further. Same as with Q3, Q5, they have the same path. Okay. And then R Q2. So now in P3, in equivalence 3, we have 5 groups. Q0, Q4, Q6, Q1, Q7, Q3, and Q5, and Q2. Okay? So that will be our states. We have 5 states. So, ano yung magiging first state natin? In this table, the first state is Q0. So which group contains Q0? Q0, Q4. So this will be the initial state. Okay? And then, if it's 0, based on this table, it will go to Q1. So which group contains Q1? Q1, Q7. So now this will be the new. Okay? The new path in case Q0, Q4 encounter 0, Q1, Q7, which is still the same since Q4 go to Q7, same group. And if it's 1, based on this, it will go to Q5, which group contains Q5, Q3, Q5. So this is. Okay? So now let's move with Q6. Q6. Okay? So if it's 0, loop within self, so Q6 pa rin. But in case if it's 1, it will go to Q4. Which group contains Q4? Q0, Q4. So this will be written for 1. And now let's proceed with Q1, Q6, Q7. If it's 0, it will go to Q6. If it's 1, it will go to Q2, final state. Q3, Q5. Q3 will go to Q2, final state. So just Q2. Q3 will go to Q6 if it's 1. So Q6. And if it's Q2, the final state, okay, will go to Q0, which group contains Q0, Q0, and Q4. So this will be written here. And then if it's 1, it will just stay with Q2, Q2. So this will be the transition table of our new, okay, of our new automaton. So just draw this one, and that will be the new drawing for our simplified automata or minimal automata. Okay, on the next video lecture, more example about this. Okay, so thank you for listening. See you on the next video lecture. Thank you.